Okay, some more notes from section 7.3, and this is example number 4. Find the volume of the solid formed when the region bounded by y equals the square root of x equals 0, and y equals 2 is revolved around about the y-axis. So now we're going to go about the y-axis and integrate with respect to y. So now our circular disc, rather than being perpendicular to the x-axis, will be perpendicular to the y-axis. Okay, so I drew a sketch, and this is my region. Y equals the square root of x, and then y equals 2, and then x equals 0, so it's this little region here. And I'm going to revolve it around, so it's going to form kind of like a top that you spin around. Okay, so I'm going to revolve this around. Okay, so this region here. Okay, so again, I'm going to be integrating. I'm going to be going from this way, so I'm going to be going from 0 to 2, because I'm going to be integrating with respect to y. Okay, from 0 to 2. So I'm going to sum these all up, and everything has to be in terms of y now. Now this is my curve y equals x squared, so I can make this in terms of y, x in terms of y, so I can just square both sides. So if y equals x squared, if y equals the square root of x, if y equals the square root of x, x equals y squared. Okay, now that x will give me the actual value of the radius. Okay, and you can check this. Now, what's my radius here? Well, my radius is 0. Well, if I put 0 in here, what do I get for x? 0. And when y is 2, what's my radius? Well, if I look at my curve here, it goes out to the point 4, 2. So my radius of my disk would actually be 4, so you could check that out. So when y is 2, x is 4. So it kind of checks out. So this actually gives you the radius. Okay? So basically we do the same thing. The volume equal to pi r squared times dy. So this is my area of my disk, and this is of my little cylindrical disk, and this is the height of it. And we'll sum these up. So r squared is y squared. R is y, so r squared is, r is y squared, so r squared is y squared squared, pardon me. Okay? And the rest is pretty easy. This is just going to be y to the 4th. Evaluate from 0 to 2. And that's just going to be y to the 5th over 5. Evaluate from 0 to 2. And times pi. And then 2 to the 5th power is 32 over 5 pi. That's it. No problem. So take a look at that. I hope that makes sense to you. And that's going to be the disk method. And now example 5. Another disk method. And now we're going to offset this a little bit. So find the volume of the solid formed when the region bounded by y equals the square root of x minus 2, y equals 0, and x equals 6 is revolved about the line x equals 6. So again, we're going to have disks that are perpendicular to not the y-axis, but a line parallel to it. They're perpendicular to a vertical line. So again, we're going to integrate with respect to y. So what I had to do is, first of all, draw my region. So it's going to be this line y equals, now this is going to be John Travolta shifted to the right 2. So this is going to be, okay, x, okay, the square root of x minus 2. So I'm shifted from here to here. Okay, and the line x equals 6 and y equals 0. So this is the region here, this region here. And I'm going to revolve it about this line y equals x, so I'll get this little dome. It's kind of like a little dome thing. All right, so that's what we've got there. Okay, all righty, and then again we're going to revolve it also about this line y x equals 6. Yes, it's going to be revolved around there, and these are going to be my disks. So the tricky thing will be to figure out what the radius is. So I'm going to figure out this radius here. Okay, well, again, there's two ways to do it. It's not going to be 6. It's going to be 6 minus whatever this is. In other words, this is 6 from here to here minus whatever this value is. So 6 minus that value will give me that. Okay, so that's the next value. Okay. So I have to get this in terms of y. So what I can do is I can say since y equals the square root of x minus 2, I can square both sides and I can say and add 2, so I can say that x equals y squared plus 2. Okay, so that's what I did. I started over here. Y equals the square root of x minus 2. I squared both sides and then I added 2, so I got x equals y squared plus 2. So this is now in terms of y. Okay, and then another method of doing this is we use top curve minus bottom curve, so we could also think of using right curve minus left curve. This is the right curve, that's the left curve. That should give me the radius also. So intuitively I can think of it as this length 6 minus this x value. See, this is x is 6. Now I have this x in terms of y. So this is the x value. So this value of x minus this value of x should give me that value of x, which will give me the radius. Okay, that's an intuitive way of looking at it. And now we can do it this little top right curve minus left curve. And the right curve is 6. The left curve is y squared plus 2. And that should give me the... And this is the value of x. And that's in terms of y. Everything has to be in terms of y. And that's going to give me the radius. Okay, so 6 minus y squared plus 2, because everything's in terms of y, that's this length, will give me that length. Okay, and I could check it out, and I usually check these out intuitively just to get an idea. Okay, in other words, what I do is I say, well, when y is 0, what's my radius? Well, when y is 0, my radius should be 4. So if I put this in here, 4 squared, 2 squared, when y is 0, I could just get 0 squared, so 2. What's 6 minus 2? 4. And when y is 2, what should my radius be? My radius should be 0. So if I put 2 in here, what's 2 squared? 4. 4 plus 2 is 6. 6 minus 6 is 0. So it checks out. So this is kind of like a little check to make sure that I'm getting the radius. Okay, so this is my radius. Right curve minus left curve. Okay, is one way, or 6 minus y squared plus 2 intuitively. Now once you have your radius, you just put it in the disk method, the disk formula. And I took the pi out, and I'm going to integrate, and this is going to be y, so I'm going to go from 0 to 2, so I'm adding up all these little circular disks. Okay, from 0 to 2, and my radius squared. My radius squared was 6 minus y squared plus 2. Okay, right curve minus left curve, and that's squared. That's radius squared. And the rest would be just working it out. 6 plus, this would be minus negative y squared and negative 2, so 6 negative 2 is 4, so I've got this. And I square that, so I get 16 minus 8y squared plus y to the 4th. I'm going to integrate that from 0 to 2. And if I take the antiderivative, I get 16y minus 8, and then y cubed over 3, plus y to the 5th over 5 from 0 to 2. And again, what happens, we just happen to luck out here. Our zeros cancel out, so we just have pi times this evaluated at 2. 16 times 2 is 32. 2 cubed is 8. 8 times 8 is 64 thirds. And then 2 to the 5th is 32 fifths. And then if you simplify this out, I didn't work out all the simplification, but if you put everything over 15, you end up with 256 over 15 pi. So you can simplify